Okay, so let's get started. My name is Vamshi Kumneni. I'm a product manager on the Azure Storage engineering team. Really glad to have you all join us for this session on Blob Storage. And I'm really excited to be talking to you today. Most of this talk is about Blob Storage and talking to you about all the new features that we've built this year, that we're announcing at Ignite, and that are coming soon after Ignite. So that's really the core focus of the talk, in particular diving into the tiered storage and archive tier that we've been building and realizing. How many of you are already using Blob Storage? Okay, many of you, great. For the rest of you, I'm going to give you a very brief introduction to Azure Storage and Blob Storage, just for a few minutes, and then redirect you to some other presentations that you can use to get up to speed. And of course, throughout the talk, we'll have real-world customer experiences and demos to really kind of bring home that story of how customers are using our platform to build these high-scale systems. So in terms of other expectations, I hope that you'll leave this session with a clear view into all the new features and the feature roadmap and how you can use them in your session. So out of necessity, there is going to be some back and forth between dev design and enterprise architecture because blob storage and object storage does straddle that line between those two audiences. And while we realize that backup DR and hybrid storage are incredibly critical parts of how customers use object storage, they're so important and there's so much to cover that we split them out into their own sessions. Backup DR is later, right after this session, actually just around the corner at 10:45. And hybrid storage was covered yesterday, and there's a recording going to be available soon. Speaking of sessions, the entire storage team has a bunch of other sessions at the conference. So I'll leave this up for just a second here. But the idea there again is if you're interested in disks or you're interested in files or our newly announced Azure File Sync service, there's a whole set of sessions. There's a few more sessions on Blob as well, as I said. There's the backup DR one. Later this afternoon, there's another breakout session covering just the big data and analytics scenario in the Hadoop and how you use the Hadoop ecosystem with Blob Storage. And then on Thursday, tomorrow, there's another session that goes more into customer and partner usage of blob storage across key vertical industries. If you're interested and you sort of see how is this applicable to other industries, we're happy to have you there as well. So let's start with what is Azure Storage, and just kind of give you a very quick, brief rundown. Storage is a core infrastructure service. So right at the bottom there, along with compute and networking, it is the service that the rest of Azure is built upon. It was one of the first services we launched. It was one of the first services we started working on back in late 2006, early 2007. It's been sort of a core piece ever since. And every other service that you see launched on Azure has a dependency on storage to store their persistent data there. It's also a building block for the rest of Microsoft. So if you're using any Microsoft service, if you're using Office 365, Skype for Business, Teams, or using our consumer services, Xbox, Skype, etc., you're using Azure Storage. Almost guaranteed both blob storage, table storage, and queues, as well as the virtual machines that those folks run, the disks and the files. So this gives us sort of tremendous scale, the combination of our internal services and our external customers using it. And we talk about blob storage and Azure Storage and sort of these adjectives. I want to touch on a couple of these. The first one is hyperscale. The scale that we operate as, is truly astonishing. And even for those of us who've worked on the platform for many years, we have trillions of objects and do more than 30 million transactions per second on average. To put that in perspective, over just the next 60 minutes, we will do more than 7 petabytes of ingress and egress across our storage platform and more than 100 billion transactions over that data. Across a year, the numbers really add up. We're talking about 60 exabytes of ingress and egress from our storage platform and over 1 quadrillion, it's 1,000 trillion transactions over that data. So truly staggering numbers. and it's really fun to have seen that service develop and grow over those years. The other point that I want to touch on is the hybrid nature. Right? With the launch of Azure Stack at this conference, we have 100% API consistent implementation of blob storage in the Azure Stack device. We work very closely with the team that ships the Azure Stack software ecosystem, and the REST API developments that we have here that we're talking about here are going to be reflected in your Azure Stack. So as you build or you use solutions that use blob storage, know that they're going to always work with Azure Stack. The other aspect of hybrid is the partner ecosystem that we have. And there's a very, very rich partner ecosystem when you look at areas, of course, like backup and DR and hybrid storage, but also industry-specific things, in healthcare, in oil and gas, in media and entertainment. We're increasingly stitching together Azure storage services into those because data is so much at the core of how we work with the cloud. Other things in terms of the service that we ship, we have disks and files. So disks are our persistent storage that you use. If you're using any Azure VM, you're using the disk service to boot the VM, and you're using this service for any data disks you attach to that VM. So it's single instance block storage. Azure Files is our shared storage. It's an SMB as a service without having to run a file server as a single point of failure. You can run a net use to or mount a device on a Linux VM, a shared storage drive. We then have our PaaS services, blobs, tables, and queues. Tables, as many of you have learned at both at Build and here, is now part of the Cosmos DB umbrella with a one NoSQL platform across Azure. And queues is our high-scale, sort of simple queuing system, if you will, that allows you to do puts and gets and build asynchronous workflows. We're going to spend most of this talk on blobs, of course, which is our object storage system, and where you have the bulk data storage, the high-scale data storage served out of. All of these services for us are built on one unified distributed storage system. So all of the benefits around strongly consistent storage, encryption at rest, security and other features accrue to all of these services as we build them together. And it also gives us economies of scale that allow us to pass these savings on to our customers. One last note about sort of Azure storage overall is, again, the geographic scale that we operate at. Because it's one of those core services and is needed to bring up the rest of the Azure service ecosystem, Azure storage is available in every region that we operate in today, 36 GA regions and 6 regions that are coming soon. So whatever you hear about in this talk is usable in every region that Azure operates in. So let's double click a little bit into blob storage and what is the blob storage service, what is it good for, what are the key differentiators from a technical perspective. So as I said, it is our object storage platform. It is where you would store your unstructured data, either through an application that you build, develop, and maintain, or through a set of partner solutions that you use for bulk, high scale or low cost storage. So it's used for data scenarios across the board. One interesting thing, if you're new to blob storage, you're going to run into is that there are 3 kinds of blobs. Those are block blobs, append blobs, and page blobs. Now, block blobs are the most commonly used object storage type that we have. So if you're using blob storage for your typical use cases, block blob storage is what you're typically using. The reason it's called block blobs is because you upload your data, or we upload it for you with the client libraries, in these discrete chunks called blocks. So we break larger files for efficiency into up to 100 megabyte chunks and upload them in parallel, and you can operate on them and things like that. So that's where the name comes from. We also have append blobs, which are good for multi-writer append scenarios. So think many VMs logging to the same file, or some kind of big data MapReduce scenarios where you have lots of output jobs, writing to the file. Append blobs are really great for that. It's really hard to kind of do that with block blobs where they're atomic objects and you can't, you're really putting them over time. And we finally have page blobs. Page blobs are actually what we build Azure disks on. So they're a very interesting kind of object where they're really optimized for random I/O. And because we had built it internally for disks, we decided to expose the REST API. So we typically see storage partners, so storage ISVs using this stuff for the efficiency and good performance on top of our system. And in very rare cases, we see customers using it. So again, block blobs are what you're going to look at most of the time. And the rest of this talk, when I say blob storage, I'm pretty much referring to block blobs. So some technical considerations for blob storage. One thing that always throws off people who are new to the platform, storage accounts are where you store your data. That's what, you get a shared key for your storage account. You can create a storage account per region or n of them per region. But we have this other concept called containers. Think of, storage accounts as your C drive or D drive, and containers as your top-level directory structure. They're great because they give you isolation between different folders. You can list stuff only within a container. So even though it looks like it's just part of the namespace, the rest of the namespace is your key. It's a virtual folder structure. The top-level container is actually a real structure. You can have isolation. You can put security policies on containers, isolate them. You can have as many containers as you want. So if you're trying to build a multi-tenant system, you would create a storage account, and you could then have a container per customer for the millions of customers you're serving off of that blob storage account. They're also great because you can atomically delete them. So if you have, again, millions of objects under a container for a particular use case or a particular month of data, whatever, rather than going through and iterating and deleting, you just delete the whole container. We also support parallel multi-part uploads, right, and range gets. So this is important if you're dealing with large files or you're trying to do scenarios like streaming and only getting parts of the object. So you can chunk the object or rechunk it for you and upload it in parallel, so large objects get uploaded quickly. And when you need to get just a small segment of an object, you can just say, at this offset, give me this number of bytes, and that works well. One very cool thing that no other cloud service provider offers with their object storage service are our objects are mutable. So what does that mean? If you have a very large object and you're just going to replace a few megabytes somewhere in the middle, most other object storage services require you to put the entire object back up again, so you have to upload everything, which is a giant pain. For us, if you build your app to be aware of this with those blocks, you can just replace the blocks that have changed and reuse all of the existing old blocks, and that works beautifully. Again, a lot of our storage ISVs use that to give you the benefits of the functionality. This one is actually used by quite a few large customers as well who are dealing with large objects. Another interesting feature is we provide optimistic concurrency support on the blob storage service. So this is basically allowing you to write lock-free architectures with blob storage. You can say, hey, if there are multiple writers to the same object, don't bother obtaining a lock unless the object has changed from the last time you wrote it, right? Because if it hasn't changed, you were the last writer and you don't have to go obtain a lock. So that allows you to build that sort of thing. And of course, we do still support locks, which is kind of nice on an object storage service because you can lock an object for just a certain amount of time or for an infinite lock and disallow writes from other writers to that same object. Now, there's a lot more detail here than I can get into here. I also don't want to bore you for people who've attended our past talks. So there are sessions from last year where we went into quite a bit more detail on each of these concepts and what you can do with blobs and what you can do with them. So let me put those up there, and then we'll use the rest of this talk pretty much to cover what's new. So let me start with this slide. Again, we talked about how blob storage and storage in general is what every Azure service is built on. What's also interesting is that blob storage has the broadest set of ecosystem support. So other Azure services all plug in some way. We, of course, talked about compute and disks, but if you think about media and media services and the CDN storage, you use blob storage for the origin storage. You use media services, uses it for live streaming. You talk about the data analytics services. You can pick stuff up from Power BI. You can pick some up from HD Insight. On the IoT side, if you're doing anything with streaming data, with event hubs, with IoT hubs, blob storage is where that data ends up, where you put it for postmortem analysis after you've sort of done the streaming workflow. So there's a great deal of integration here that allows you to then build these follow-on scenarios. One example of this is in the big data space. If you look at the sort of the over the top, the ingest and ETL, streaming, analytics, aggregation, and presentation layer, Azure offers a very rich set of services to do all of those things, including the Azure HD Insight, which is our managed Hadoop cluster service. So that's a really great service that you can use to bring all of your Hadoop ecosystem knowledge to Azure and have it, still use Azure in a very open way. The interesting thing about that is, from a blob storage perspective, every one of those services integrates with blob storage, right? So when you look below the hood, you can read and write your data in blob across all of these scenarios for big data. I'm not going to spend a lot of time on this, but I wanted to put it up there and encourage you, if this is something that you're interested in, please go to the talk this afternoon at 2:15. My colleague Chris will really be spending a lot of time walking through these scenarios. Another thing that blob storage is really good for is if you're building any kind of platform as a service or an application, etc. And the reasons are pretty straightforward. You can really start as small as you need to be, a few gigs, pay us a few pennies a month, and scale up to a few tens of petabytes, and not really worry about provisioning and all of that. It's pretty much instantaneous. The geo-accessibility is an important piece, making sure you meet data residency needs, data compliance needs when you store your data for different customers that you're addressing in different countries. And of course, one of the most important things we always look at when we're building a business together is cost efficiency, right? It can't cost a lot of money to do this. There's a bunch of scenarios, we've talked about all of these, that it does apply to. But rather than kind of go on in this vein, let me kind of switch gears and talk about a customer scenario that's really leveraging blob storage and has leveraged it from day one to build their business. So I'm going to talk about TELD, which is a company in China that provides electric vehicle charging terminals. I had never heard about this until some of my colleagues in China kind of plugged me in with them and sort of talked about what they're doing. But it's a really amazing story, and I wanted to highlight that. So they are China's largest electric vehicle charging provider. They're a really fast-growing startup. They've went from 2 people to over 2,500 people in 3 years. And they just closed $1 billion funding round in this year to continue that sort of exponential growth. So they operate a network of electric charging vehicles in 240 cities across China, and their growth has been pretty amazing. They sent me this data of how they grew from 2014 to today. So they run 13,300 charging locations with over 170,000 charging terminals across China today. What's cool about that is they've been on Azure from day one. So they said they picked Azure because they knew coming in that they wanted a cloud focus, that they didn't want to go build their data centers, and they really wanted to focus on what was important to them, which is getting those terminals out there, getting them deployed. That was their core engineering focus, is that part of their business. And then they trusted Azure and Microsoft to provide their cloud needs. So what do they do with us? So you go in, you're driving around an electric vehicle, you plug into a terminal. That terminal sends data. Every one of those 170,000 terminals sends data to blob storage every 30 seconds about what's happening at those terminals. So that data arrives in Azure, it gets transformed by a bunch of analytics VMs, and then gets stored in Hadoop clusters, both in HBase as well as some Spark processing that they do on that pipeline. Then their operations team uses this data for monitoring. So they have alerts firing off of this, they run HBase queries for certain things. So they're really looking at the health of all of those terminals and locations using this data on top of Azure. They also are able to push command and control operations back to those terminals through this TLD management platform that runs on top of Azure. So they're not only able to receive this data, but able to do things like turn off terminals or send them some control commands on what they're doing based on the health indicators that they're getting up from there. They also use this data to provide a consumer experience. So if you're a customer of theirs and you have they have a mobile app that you pay with and do all of that, they allow you to start and stop charging, they allow you to check your balance, they allow you to check your charging history. All of that is run off of this data set. So as you can imagine, doing this in a timely fashion is very, very important to them. They're at 170,000 locations and growing, so making sure this pipeline flows smoothly is important to them. And they're using them for pretty core purposes, both for their administrative command and control structure, as well as for their core customer experience. So this is a really great scenario because it's kind of this high-scale sort of IoT scenario that's flowing through blob storage, flowing into a Hadoop cluster, and being used that way. But TLD isn't stopping there. They're starting to use this data to make business decisions. So they're using the data that they're collecting to say, what do we do around failed terminals? How do we address them? How do we look at demand curves across the day and figure out where we need to add more terminals or where we need to add more locations? They're using it for business expansion. They're also using that data, starting to use that data for enhancing the customer experience, telling them when, better than their cars are, when they should be charging, where they should be charging, things like that, so customers have a much smoother experience with their electric cars. They're also going to do a bunch of other things that, including leveraging our cool and archival storage so they can keep more data longer for these business decision-making type processes. Moving to containers with our Azure Container Service container instances for better utilization of their server farms. And then they're going to use Azure for geo-expansion within China, but also beyond as they expand in other parts of the world. So it's a great story. Really enjoyed chatting with them, talking with them. I don't know if Chiang is here. I know he was tied up in traffic. But their VP and Chief Scientist is at Ignite. I think he'll be here by the end of this talk. So please, chat with him if it's an interesting scenario. We really enjoyed working with them. So for the remaining part of this talk, in terms of talking about new features, I didn't just want to go a whole bunch of slides saying, here's a new feature, here's a new feature, here's a new feature. I tried to put it back in terms of those adjectives that we showed right at the beginning, in terms of the core architectural pillars. So I'm going to use these pillars as a way to structure all of our new feature announcements in the way they fall. So let's start with durability and availability. I'll talk a little bit about what we have and what we're announcing in each of these sections. So the first thing that we do in terms of durability and availability, that is probably the most critical thing that any storage service has to do. First rule number one, don't lose your data, right? And make sure your data is readable when you need it to read or write. So the first thing we do there is strong consistency. We have 3 copies, strongly consistent. So when you make a put object or put blob, we guarantee writes to 3 different disks on 3 different racks and return that rack to you only when that has happened. We then erasure code that data in the background to make sure we get you that cost efficiency as well. We check, of course, on input and output, we check with MD5 hashes the data integrity. But we're also doing constant lazy scanning of the entire data set that we store with CRC checksums looking for bit rot. Because we have multiple replicas or multiple fragments with erasure coding, we're able to detect these issues and fix them so you never have to worry about them. We provide BCDR protection and force majeure event protection with GRS. I'll talk a little bit about that in the next slide. And of course, we provide a financially backed high availability guarantee. Our real observed SLA for availability is much higher than this, but this is what, if you ever fall to this level, we will make sure we give you money back for having not met those SLA guarantees. So on the durability front, let's double click a little bit more into that. We have what we call locally redundant storage. So that's the 3 copies in a single data center that I talked about, synchronous, strongly consistent. And so it's in a way that you never have to think about, even for your disks, running them in a RAID configuration, because we're doing better than that for you. With GRS, we replicate asynchronously that data to another data center at least a few hundred miles away. That way, if the entire region suffers some kind of catastrophe, you're protected. And read access GRS allows you to read that secondary copy, because you may want to use it for high availability. If this primary region has a blip, you may want to validate that the data is there. You may want to check how far the lag is, etc. We do allow you to read that with a different secondary endpoint name. So what are we adding here? So we're adding something called Azure Zone Redundant Storage, built on, and this is sort of version 2. For those of you familiar with Blob Storage, you know that we had a ZRS offering. But on the backs of the new Azure Availability Zones, we're improving Zone Redundant Storage to do synchronous commits to 3 copies in 3 different availability zones. So that's kind of the difference between LRS and this new ZRS, is you're going to get a synchronous ACK, strongly consistent, but it's going to be committed to 3 different data center buildings. So you're also protected against a data center failure or a cluster failure. This is something that is coming up for public preview later this year, and we expect to GA it in the first half of next year. Of course, this is dependent on the regional availability of availability zones, but as you've heard at other parts of this conference today, there's a commitment to expand that to many, if not all, Azure regions. So let's talk a little bit about security and compliance. Once you have durable data, the most important thing that we're running into has been such a topical thing in recent days, in the recent few weeks or months, with the amount of data breaches and data leaks that are unintentional data exposure that's happening, that you need to know that your data is secure and it's compliant. So there's a few layers. We start with encryption at rest, and making sure that your data is always encrypted at rest. So if there's any kind of physical loss of disk or whatever, your data is never in a form that somebody can read. We launched this service at Ignite last year. We GA'd it for blobs with Microsoft Managed Keys. We've since extended it to our other services. And we've been running this now for a while. And one of the things we're starting to do now is we're enabling encryption by default for all accounts, because we feel very confident about the perf implications and what our observed behavior has been. It used to be an opt-in, now it'll be the other way. It'll be enabled by default with Microsoft Managed Keys. Another ask from customers who've seen this feature is, when do I get to supply my own encryption key, and how do I do that? So we're pleased to announce that that's in preview. You'll be able to go use it today. And you can either provide us a key URI or store your key in our HSM as a service, Azure Key Vault, and we'll then use that to encrypt it. So if you, for example, revoke that key, we will not be able to decrypt that key. You control your encryption keys and the encryption of your data. We also encrypt data, of course, in transit. We've always supported HTTPS as a transport protocol, and we've always allowed you with shared access signature tokens, for at least for a while now, to restrict access to HTTPS only. Again, based on customer requests, we have an option now to say secure transfer only. So we disallow any HTTP request coming up. So there's no possibility of the data being delivered back in plain text out of your storage account, even to an authenticated user. So you can just turn that on with a single click on your storage account, and we'll make sure we respect that. We also have a feature that's been asked for a long time, and we're building on the virtual network service endpoints. We're announcing a new feature here called firewalls and virtual networks, which really allows you to protect the storage account, the public endpoint, and not have it accessed from places you don't want it accessed from. Right? So if you lose the key or you lose permissions, etc., if the person is outside the virtual network that you designate, or the IP address range that you designate. So let's say you have a company and you say, this is my company's IP address range. That is the only IP address range that's allowed to access the data. Any other requests, even authenticated requests coming in on the public internet, will be rejected. So that's what this feature does. And it's basically something that is in public preview. The blog post goes out, I think, later this morning. So you'll be able to just go use this in a few regions, try it out, give us feedback, and again, we expect to GA this fairly soon. Another piece of feedback that we've gotten from our customers is, hey, that shared key, shared access signatures is great, we use it, but when are you going to do AAD authentication? When are you going to do full role-based access control? So we're again pleased to announce that we're working on this right now. And today we support it at the control plane so you can protect your storage accounts. But what we're working on is the AAD and OAuth support, so the Blob Storage REST API itself. So all of the data operations can be protected that way. You can have your roles assigned, fine-grained roles on your AAD tenants. And remember, these are the same AAD tenants you might be already using for Office 365. So you're not reloading, all your user sets. You're just leveraging that to provide permissions. And these will be integrated at the container level. So again, that notion of containers at a top-level directory, you can scope different parts of your blob storage account differently for people. So this is something that we're working on. We don't have a date yet, but we're actively working on it, and we hope to preview this soon and then GA. Another aspect of data protection then is immutable storage. So customers have asked us over the years, hey, for compliance reasons, I'm required to show that the data I write into blob storage is tamper-proof, hasn't been tampered with. So here we're announcing worm storage, where we give you the ability to upload data, then set a container policy on that and say, after this point, do not allow it to be deleted or overwritten for the number of days, months, years that you set on that policy. And you will have audit logging, you will have this nice retention interval. And what's really cool here is this is going to be available for all the blob tiers. So you can even protect your hot and cool data, not just your archive data. Any tier data, if you want to write it in, if it's active read data, you can still protect it with worm protection and make sure you don't allow deletes or overwrites. We will be doing this in a way that has strong compliance. So we're working on getting the legal opinions necessary for the SECs, the 17A3, 17A4 compliance, support for legal hold, which is a common concept in this area. And at the same time, making sure we can give you a good path for compliance archives and having really low cost for compliance archives. It's one of the biggest cost pain points for large enterprises is maintaining this data for years and years for compliance and regulatory reasons. So preview for this late this year and GA first half of next year. So let's switch gears again, talk about manageability and cost efficiency. So you've got your data durable, you've got your data secure, and the next question is, how do I manage it? How do I monitor it? How do I know what's happening? And how do I also know that this is a cost-efficient way for me to store my data? On the monitoring front, we've had Azure Storage metrics and logs for many, many years now, since 2011, I believe. But there's this new service called Azure Monitor that pulls everything from across all the different Azure resource providers into a common data store, gives you common visualization, common REST API, etc. And we've been working with that team to integrate all of the storage analytics that we have into Azure Monitor. We've also, of course, been a sink for that data, so we're able to take data from Azure Monitor, put it into a storage account for later analysis and things like that. So the metrics are in public preview now. You're able to use this. If you just go to Azure Monitor, you're able to set up your storage account in Azure Monitor, look at all of those metrics. And there's a set of documented metrics that are available today, from capacity container, capacity metrics to usage metrics, things like success ratios, latency, etc. on your blob storage. We're also going to add full diagnostic log support into Azure Monitor, so you get that trace statement-like diagnostics that we have today, but it'll be fully integrated into Azure Monitor, the ability to query that with App Insights and other services. We're also adding a feature for data protection. This has been a very common ask for us. We get a number of tickets, I'd say every month, that people say, hey, I accidentally deleted my blob. Can you get it back? Blob deletion today is permanent. There is no way to get it back. You call delete blob, it's gone. So we've had that feature asked for a bit, and we now have a feature called soft delete that you can set a configurable number of days to retain your data yourself. They go into a hidden mode. You can say list blobs for all your deleted blobs, and then you can actually restore the blobs yourself. So you can, of course, turn this off. So if you want permanent deletion, you just set the number of days to 0 and we'll delete immediately, but you can have that. It is blob level, which is nice. So if you call any delete blob, you can go list them, you can recover them. I'm showing you the portal screenshots. You can do this via API or PowerShell CLI, of course. The intent for us is to GA this in H1. We'll look at when we do a preview, but this is something, again, our dev team has been hard at work on. We're going to extend this after we release this feature to object versioning. So full-blown object versioning, this one will give you delete protection. Object versioning will give you a version per object. So every time you overwrite an object, you put a new object, you get a version ID, and you could use that in your applications. So that's kind of the coverage on manageability. Let's talk a little bit about cost efficiency. And our approach to cost efficiency is what we call tiered object storage or tiered storage. We know that cost efficiency and scale are two very core tenets of object storage. It's why customers pick it. It's why customers write code against our APIs. The way we think about this, and the way I think many of our customers think about it, is data has different temperatures over its life cycle. There's HSMs, hierarchical storage managers, have existed forever on premises. This notion of tiering data through different tiers from hot to cold has existed for a while. Our first take on this launched last year, where we offered hot blob storage and cool blob storage accounts. So at the account level, you could put data into the hot tier or the cool tier. The nice thing that we did is we said it's the same API. So you're not rewriting your applications, you're just choosing a destination for that API. So this is something that we've released in April of last year. We've been learning, talking with our customers, looking at how they use it. And we're now ready to kind of talk about the next set of announcements. So to start with archive storage, let me call my colleague up here, Kamal.
Thanks, Vamshi. My name is Kamal Hussain, and I'm a PM on the Azure Storage team, specifically leading the release of archive storage. Now, last month, as many of you may be aware, we launched the public preview of archive storage and blob level tiering. And I'm excited to share the details of that with you today. However, what I'm really excited about is introducing two of our customers that will demonstrate how easy it is to use this new storage tier and the significant cost savings that your organization can realize. Archive is our new cold storage tier that is intended for data that will be kept for long term, is rarely accessed, and can tolerate several hours of retrieval latency. As you would expect, as you go from the hot, cool to the archive tier, your storage costs come down. However, your access costs do go up. So it's really important that you understand the read access pattern of your data and place that in the appropriate storage tier to really optimize your costs. Archive is the lowest storage tier that Azure offers today. So there's a significant amount of savings that customers can realize if used the right way. One of the greatest things about this offering is that we've managed to integrate it in current blob storage experience. Now, what that means is that every valid archive operation is the same API that you use today for hot and cool storage. You can seamlessly integrate this into your apps and application with very minimal changes. The next thing I'd like to introduce is blob level tiering. If you use blob storage accounts today, you're familiar with hot and cool storage accounts. The access tier is set at the account level. And if you want to use both of these, you have to manage the complexity of setting up separate accounts and moving data between those accounts. With blob level tiering, you can now set the access tier at the object level. What this means is that for every blob, you can move it from one tier to any other tier seamlessly. The tier change happens immediately in all scenarios, including moving a blob to archive. However, the exception is when you move a blob from archive back to hot or cool, which is a process that we refer to as rehydration, and that can actually take several hours to complete. When a blob is in archive, the data is inaccessible and can't be read. However, the metadata is still available and online for you. And you can use the same APIs, get blob properties, and list blobs for all your blobs in archive. We have two new headers that we're introducing called access tier and archive status, and these will allow you to view the tier of all your blobs and then also know what the status is when a blob is rehydrating. Now, this is really great, but it still means that in order to optimize your costs, you will have to write some scripts to take advantage of this. In the future, though, we are releasing automated lifecycle management policies. And this will enable you to set up policies based on various conditions, such as last access time or blob creation time, and automate the tiering process. In the interim, we do have a solution using Logic Apps. So Logic Apps is an Azure service that will automate a series of steps into a workflow. And now we also support set blob tier and list blobs with this service. So what you can do is very easily, as you can see on the left, set up a template where you first specify the frequency of how this should run. So in this example, I have once every 30 days. I then list the blobs, loop through each blob, and check the last modified time. I compare that value to the current time and check to see if the blob is older than 30 days or not. If the condition is true, I then call set blob tier and move the blob to archive. Now, this is a very simple way to automate this and set up something that you don't have to worry about. But to make it even easier, we've created this as a template. You can access this starting next week, and it's called Blob Data Lifecycle Management Template in Logic Apps. Now, you may be wondering, this seems like a really great service. I can save a lot of money, but what exactly is the type of workloads that this is intended for? So here are just a few of the examples. Long-term backup, disaster recovery data sets. This could also include a second copy of your backups that you just want to keep in the cloud. Any type of original data that's processed. So for example, raw media files that are encoded or transcoded that still need to be kept around for a while. Medical records, so x-rays, ultrasounds, CAT scans, all of these after a while aren't accessed frequently, but still need to be kept around for several years. And then finally, business compliance and legal compliance data. So this could include financial and tax records, employee information, security footage. All of this data are great examples of things you can keep in archive and significantly save money on. IDC recently published a paper where they projected in 2025 that the total global data sphere will reach 163 zettabytes. And 60% of that will fall into the archive classification. Now think about that for a second. That's almost 100 zettabytes of archive storage that we will have in just a matter of 3 years. And unless there's a very cost-efficient and scalable way to store this, it's going to become very expensive for organizations. And we think the archive storage tier will help with that problem. Now I'd like to quickly go into a demo and show you how easy it is to use this feature in the portal. And then I'll hand it over to Gaurav Mantri, who is our Azure MVP extraordinaire and also CEO of Synapta Software, who will demo a very cool cost analysis tool that he built.
Thanks, Kumail. Good morning, everybody.
Let me go first. All right. So here you can actually see the portal experience. So I've logged into my account, and I have a bunch of containers here. So let me just click on one of them. And let me zoom in. And so here's your typical container view. What you'll notice now is that there's a new column called access tier. So I have blobs in both the hot, cool, and archive tier, all within the same container and account. So if I click one of the blobs, the get blob properties pane shows up on your right-hand side. And if I go all the way to the bottom, there's now a new drop-down field called access tier. And let me zoom in so you can see that. So all I have to do to actually change the access tier is to click on, let's say, for example, cool. I click save, and bam, it's done. Now let's say I want to move this into archive. Same exact process. I go, select archive, click save, and now it's in archive. Now, as soon as this is done, and I click save, I am now being charged archive billing rates. Now, if I want to access this, I need to rehydrate it back to cool or hot tier. So to do that, I follow the same process. I click hot, and then I click save. Now, the difference here is that what you'll notice is that the access tier actually didn't change. All it did was it grayed out the archive access tier, and there's a note at the bottom that says the blob is currently being rehydrated to hot, and it'll take several hours to complete. And just to prove to you that this works, we're going to now wait here for a few hours while this process is done. No, I'm just kidding. You'll have to take my word for it, but if you see me afterwards, I'll show you that it actually did work. All right, and with that, I'll hand it off to Gaurav, who will go over the demo.
Good morning, everybody. So one of the things, one of the key confusion is when we are dealing with object storage in the cloud is, how much is going to cost us, right? I mean, there are many costs to consider. There is storage cost, there are read cost, there are write cost, and things like that. So what I have done is I have actually created a command line tool that can analyze files that are either in your local file system or a file share, or if you have blobs in storage, and then, so it will do a cost analysis for you, and it can tell you that, hey, whether, you are better off keeping them locally or, keeping them in one particular access tier, or, will you be better off keep moving them to an archive tier or something like that. So what I want to do is I want to start off with a scenario where, all right, so where you have a scenario, so you are not in the cloud, you have, sorry about this. So essentially the scenario is that you are not in the cloud, you have lots of files, backup files that you are keeping on your computer or on a local file share, and you want to see, what would be the cost if I were to move these files from my local file system, local file share to Azure Storage. So let me quickly run this analysis, and right now what I'm doing is I'm analyzing a particular folder on my computer. It has about 800 gigabytes of data, and as you can see, if I were to move these things in hot access tier, I'm going to, it's going to cost me about $14 a month to store that data. As I move, to a cooler tier, my storage pricing is going down. So that's scenario number one. You can decide whether, moving files from local file system to Azure Storage makes sense for you. The next scenario that I want to cover is you already have some blobs. So already you have some blobs in hot access tier that you have put in there, and you are never ever going to read those blobs. So does it make sense for you to move these blobs from hot access tier to archive access tier? The storage account that I have has a lot of files in there. It holds a lot of data. So what I have done is I've already run the analysis, and I just want to show the results of this analysis to you. And as you can see, I have about 5 million blobs occupying 300 terabytes of data, and you can see that to store these files in hot access tier, that's what I'm paying right now. I'm paying a little less than $6,000. But if I were to move these files onto an archive access tier, right, my cost has gone down considerably. Now this is based on the assumption that I am not going to read these blobs ever, or very, very rarely. So in this particular scenario, yes, it makes sense for me to move these blobs from hot access tier to an archive access tier, right? And so that's scenario number one. The second scenario that I want to cover is, what if you have blobs which are there in your hot access tier, and you still want to read a portion of that data, right? So, so I have, in my storage account, I have 300 terabytes of data. Let's say I want to read 30 terabytes of that data, 10% of that data. So, in this scenario, what I have done is, I've run the calculation, and as you can see, if I move these 300 terabytes of data from hot to cool, my storage cost has gone down. It has not gone down that much as compared to the archive thing, but it has gone down considerably, right? There is a read cost associated with the cool access tier. So, that I have taken into consideration. But then, overall if I see my net savings, I'm still very good. I'm still saving, 50% of that data while, still retaining the read capability, right? So, that's scenario number 2. Again, in this scenario, this makes sense. The third scenario that I want to do is, I have blobs in hot tier, I want to move them to cool tier, but I want to read this data, very often. Say, each blob in my storage account, I want to read 4 times per month, right? So, 300 terabytes of data, that means, I'm reading like 1200 terabytes of data every month. Now, in this case, again, because I'm moving the blobs from hot tier to a cool tier, my storage cost has gone down, but if you will notice, my read cost has gone way up. Right. So, so from, it is now like $12,000 per month just to read the data from the cool access tier. Now, in this scenario, obviously it does not make any sense for me to, move this data from hot tier to cool tier. So, I guess the point that I'm trying to make is that, you have to take all the costs into consideration and not just look at the storage cost that, okay, the storage cost is 50%. So, don't just take the storage cost, so, analyze your read patterns and see if moving the blobs across tier makes sense to you. As Kumail mentioned, the code actually to, change the blob access tier is ridiculously simple, right? All I have to do is, so I'm using this storage API, and this is the method that I will call, and it will change the tier of a blob from hot to cool or archive or rehydrate the blob, that kind of thing. This tool is available on GitHub, so please download it, and it's also available in .NET Core. So if you are using Mac or Linux, you can run that. So we look forward to you using the tool and giving us feedback. Thank you.
Thank you very much, Gaurav. I think this is a really awesome tool, and you can check back later and view this slide to actually get the link for GitHub. All right, now timeline. As I mentioned earlier, this feature is currently in public preview, so all you have to do is go to the link below. It'll take you to the blog, and at the bottom of the blog, there's some instructions on how you can enroll. Currently, there are some limitations in that only LRS is supported. It's only for blob storage accounts. However, at GA, which we expect to be by the end of this year, we will have GRS support. Also, if you have general purpose account, they currently don't support tiering, but we'll have a new general purpose account that will, and you'll be able to opt into that through a one-click system very easily as well, and that will support archive. And then finally, there's a bunch of stuff that we're working on. Some of the things that you can look forward to is data lifecycle management policies, faster retrieval times, and then ZRS, which Vamshi went over earlier. In terms of regional availability, preview is currently only in US East 2. However, for GA, we will be in 14 regions globally. So this includes all 8 public regions in the US, EMEA, Korea, and India. However, the blob level tiering functionality, the ability to go between hot and cool at the blob level, that will be available in all regions when we go GA. We've been working with several storage partners to have this supported. And these are the list of partners that will have support for archive storage when we go live in GA with the service. Several of them also have archive storage support in preview. So if you're interested, please come talk to me afterwards and I can give more details on that. And with that, I'd like to hand it over to Tom from BP.
Good morning. So as you can see, the team from Microsoft has been building a lot of killer features into blob storage.
And I want to give you one real-life example of how at BP we've been working with them to build an application to bring some of these features to life. So, as with every big company, and I'm sure a lot of you experienced this, we've had a lot of shortcomings with our data management options on-premise in the past. Some of the things, and I won't kill it, but expensive storage cost. On-premise, it's a real pain. You have to size and buy everything up front. You have to figure out where to put it, maintain it, refresh it. As people and organizations change, you have a real lack of data ownership. People move on, and eventually you collect, massive amounts of data, but you're not really sure who the business owner is. It's scattered across different solutions, file shares, email, SharePoint, tape, optical storage, depending on the generation, and these problems compound on each other. So, if you have to maintain 4 or 5 different systems, that problem that I've outlined around the storage cost just grows. Finally, if people haven't been very good about attaching storage retention codes or applying metadata at the time of creation, you don't know if you can delete your storage or not, right? What's the risk of deleting it too soon? What's the risk of keeping it? Some companies will just keep it forever. And then finally, how do you deal with legal compliance issues? So if something's under legal hold, how do you make sure it becomes immutable? What do you do with old business records when you retire an ERP system, but you need to keep them in read-only fashion? So these are real challenges we've faced in BP. I suspect a lot of you have the same challenges in your organization. And we've been working with the Microsoft Storage team for a while in terms of building a web app. So the availability of, the scale, hyperscale public cloud really changed the dynamic in terms of making it attractive to build this sort of a solution. In the past, when we would try to do an archiving project, because you require a lot of spend up front, you have a very slow payback, it's just not a very sexy proposition, and it's one of those things that is easy to defer for another day. So we've worked with the team here, and we've built ourselves a web app using the Microsoft Azure cloud. And we've really focused on keeping our overhead low and keeping our costs down and giving our business users every reason to use it. So it's a self-service archiving application. We call it Attic. It's built entirely on Azure PaaS, so a serverless architecture. We leverage hot, cool, and cold storage, or hot, cool, and archival storage blobs. And we've been in private preview for a while. And finally, we've automated all of the workflows that we can on the back end so that the user process goes seamlessly from end to end without a human intervention. So a little bit under the hood, at its basic level, we have a simple .NET web app that allows the users to do everything they need to do around creating an archival request, creating a retrieval request, searching across the metadata, or browsing the catalog. Once we know specifically what it is we need to archive, the data gets staged on-premise, and we run a web job we call file info, which creates a catalog. So it does checksums and indexing on the files so we know exactly what we're sending. That data gets stored in an appropriate Azure SQL database. Finally, we use ExpressRoute and IBM Aspera to send the files up into the blob store. We take full advantage of the encryption in transit and encryption at rest features that were talked about previously. We run a final sense check to make sure that what we've uploaded fully matches what we did our checksums on before. And then across the top, we have a Cosmos DB for user-defined metadata schema and Azure Search across the top. So what were some of the benefits we found from running this project? First of all, the serverless architecture built on Azure PaaS is far cheaper than standing up that sort of infrastructure on-premise or even on IaaS would be. You can start small, it's quick to deploy, it was really quite quick to build, and costs tens of dollars a day to run, right? The Blob API allows us to control the lifecycle management policy and object tier. We can put those workflows directly into the application, and in a completely hands-off way, you only pay for the storage you need for the data as it gets accessed. A lot of options are provided by Microsoft for ingress and egress of data. You can ship disks. You can use the new Azure Storage box that has been announced this week. You can ship things over the wire. If you have ExpressRoute, you can use that. And you can use tools like we do, such as Aspera, which is a great accelerator. The fully managed indexing is really convenient. Azure Search Service works a charm. And then finally, the built-in security keeps our digital security and compliance people happy. And a lot of the industry, or a lot of the businesses we're in are highly regulated, and so having all of that built into the platform helps keep everyone secure. So with a soft launch and a little bit of internal publicity, our customers archived 5.3 million files in the first 6 months. The project paid for itself in less than 6 months. With the low prices that are announced today, those savings will continue. A real intangible benefit, because we are now enforcing retention codes and security policies, that we have better retention and compliance. And finally, it's a fairly simple offer. And so it's available and free for all of our businesses to use, which gives people really no reason not to. And so, using the tools that have been provided by Microsoft, we're giving our business a reason to do the right thing with their data instead of putting off the decision for another day. All right, thank you. Vamshi.
Hey, thank you, Tom. So you've heard about tiered storage, archive storage, and blob tiering. It's available now in preview, as Kamal mentioned, on blob storage accounts. You can go use it. The blob level tiering is in preview everywhere. The archive tier is only in US East 2. You saw the GA plan there. We will also, and it's worth stressing, if you're using general purpose storage accounts today, give you a one-click way without moving your data to upgrade your accounts to a tiered storage account. This is one of the feedback pieces we got from blob storage accounts. People were like, I'm using the other type of accounts you already had. How do I get, I don't want to move my data, copy my data over. So we will have at launch a way for you to not move your data and just take advantage of these new features. So let's switch gears again, using that pillar guide, and talk about scale and performance, which is another area where we've made tremendous improvements over the last year. At the end of last year, we launched larger block blobs, so moving from 200 gigabytes to 5 terabytes, really helpful for places like media and entertainment, where the 4K and 8K master files are much larger than a couple of 100 gigs. We also made a lot of improvements on write throughput, so you can use those large objects in a timely manner. Even for folks using small objects, less than 4 megabytes, we've made a number of improvements that improves the read latency in particular, makes it much faster than it already was. One of the things we're announcing here is storage account scalability. Many of you know we've had this limit of 500 terabytes per storage account for a few years now. Back then, in 2012, sounded like a lot of data. It isn't really anymore. So our first phase of this expansion is 5 petabytes. So all blob storage accounts today, you can go up to 5 petabytes with no issues. You can also take the transactions per second and the ingress and egress and bump that up as well to 50,000 transactions per second, 50 gigabits of bandwidth, and you don't need to shard your data. There's a lot more coming. This is sort of phase 1 for us in terms of our expansion of scale limits. We'll have more to talk about at the end of this year and into next year. So keep in mind that this is sort of our stepping stone to getting to truly limitless accounts. And one of the other things that we've done as we've gone down this path is optimize this for HPC and big data workloads, because that's really where we see a lot of throughput transactions per second. Capacity, of course, is across the board, but we've really spent a lot of time optimizing those transaction and throughput pieces to also scale with your capacity scale. You have these large accounts. How do you get data in? So if you have good connectivity, you can think about getting it in online, right? Over the internet is definitely a possibility, but what we generally run into is our customers have a bottleneck right at their site or their colo in terms of how much ingress, egress pipe they have. If you have great pipe there, you should just use the internet, it works well. In remote locations or long latency scenarios, we've partnered with both Aspera and Signiant. So these are both well-known accelerated upload agents that allow you to get that data in there quickly. If you need more bandwidth, you can go provision an express route. And we have a much expanded list of telcos that provide those express route connectivity to your data center or your premises. And you can have these links not only provision, but also secure. The data is not flowing over the public internet. Today, you can do up to multiple 10 gig links. A single 10 gig link will allow you to upload about 3.2 petabytes. And remember that it's actually what we provide is an active. So even though we say 10 gig, you can actually burst up to 20 gigs if you need it. So which allows us to actually push the full 3.2 petabytes of ingress and egress per month with customers who have these things. What if you're in a place where you don't have good connectivity? We've had the Azure Import-Export service for a long time now. They support up to 10 terabyte SATA drives available in many regions. But one issue here that we've run into and our customers have run into is it requires you to go buy disks and then prepare them and load data on them and ship them over. So we launched this at Ignite. This is our Azure Data Box. It is a nice little device that allows you to rent a box from us rather than buy a bunch of hardware, transfer 100 terabytes up to 100 terabytes of data in less than a week. When you plug this into your network, it has two 10 gig NICs at the back. It gives you an SMB share. You just copy your data, you do a little bit of manifest creation, tell us that you're shipping us this box, and we'll take care of the rest. It doesn't use encryption in transit again. So it's all the data you write on there is encrypted right there with AES-256 encryption. So if the device goes away in the middle for some reason, you're not losing your data. We also provide clear chain of custody tracking all along the way. This is in preview today. You can sign up at aka.ms, Azure Data Box. Again, this would not be very useful if you didn't have a partner ecosystem around it because you're not just getting raw data in there, you're getting data that you're using with one of your backup vendors, with something else. So we're working closely with a bunch of partners, including the ones shown up here on the screen here, and we will continue to expand the ecosystem of partners who support the data box to get your data in, to seed your data, or to get an ongoing data pipeline going. So with that, in terms of scale, I'd love to have Arkady come up here and talk a little bit about how Comcast is using blob storage at scale today for their production needs. Thank you.
Good morning. Today, I would like to share our experience working with Azure Object Store for our Comcast Continuous Video Recording Service. This service was developed about 1.5 years ago, and it's available for Comcast, home security, and high-speed data customers. So the way it works, it captures videos 24/7 from customers' cameras deployed at customer residence, and then the customers can play the video back in the live streaming format. So as we start implementing the service, we understood that the service consideration is one of the key components of making it a quality service. We wanted the service to be scalable, performant, with 99.9 success rate, availability with low consistency for retrieving the videos. And as we'll move along, we initially implemented our solution using the Object Store, part of the OpenStack cloud solution deployed at Comcast premises. However, very shortly we realized that this storage solution does not meet our requirements, and we moved to Azure Blob Storage. As you see, this schema is very simple. The camera uploads segments every 15 seconds, and our service stores upload the blob into cloud, and then stores video metadata in Cassandra database. On the playback, customer uses mobile app or web application to see certain portion of the video based on the time range. As we scale our solution from a few thousand of cameras to hundreds of thousands of cameras, we learned quite a lot. And we came with this architectural decision. We use non-blocking HTTP requests for making requests to upload videos to Azure. We also use custom retry policy, which is also non-blocking, and it also using configured backoff periods. We definitely saw advantage of using multiple storage accounts, and I will go into more details as I go along. But basically, having multiple storage accounts allows us to do traffic distribution, dynamic load balancing, and the failover. So let's look at the more details on each element of our technical decisions. Asynchronous versus versus blocking I/O is in itself not a problem. Modern JVM can handle multiple execution threads and no problem, but if you run at high scale, you will see performance degradation, especially if your service is CPU bound. So in normal blocking HTTP request, each execution thread is bound to request. Request may take 3 seconds, may take 10 seconds, thread is blocked. If you have huge scale, then the number of threads that JVM has to manage increases, and thread is relatively heavy object. You need to do context switch between threads. So while, again, as I said, it's not a problem for a regular load, for high scale, it is a problem, especially if your service is CPU bound, as it's in our case, because we need to extract the images from the segments. So what we use as our platform of choice was the Play framework with Scala language. It's actually very easy to set up the non-blocking HTTP request because Play framework has a nice abstraction, a nice helper to do that. As you can see, it's very simple to do upload, and while the upload happening, the thread is completely out of context and used for something else. It only gets allocated when response is received. Sometimes, as we discovered, you get spike in throttling errors, 503 errors. And the first remedy for this is to do retry. But you don't do retry right after another. You need to wait, as Microsoft Azure engineers explained to us, and then retry again. And again, Play framework to the rescue. It has built-in scheduler, and it's very easy to set another upload retry after pre-configured amount of, say, 3 seconds. And as you do next retry, you increment the retry count, so you don't retry forever. When the number of retries reaches a certain limit, you fail. This request fail. So again, multiple storage account. Initially, we thought that, okay, we have so much aggregate size, and the limit on each account is so much, so we need to have, you know, multiple accounts. But as we discovered, just to provision the number of accounts based on the size alone is not enough. We want to provision more accounts because it gives us more flexibility as far as failover, as far as distribution between different data regions. And the first thing we needed to solve is you have many accounts, how you distribute load between them. We found that it's very useful to have explicit way to control how much load goes to every account, to each account. Think of it as a percentage of the load. So I want the account 1 to have 5% of the load, and I want the account 2 to have the rest of 95% of the load. How we can solve it with a solution that is lightweight and stateless. So we use consistent hash of the camera MAC address. Camera has a MAC address, it's a unique camera identifier. And what happens, because we have so many cameras, if you perform mod operation on the camera's MAC address over 100, it gives you even distribution for all the cameras between 0 and 94. So now, sorry, between 0 and 99. So now you will have the idea, so you could convert each percentage on the account into a range, and the higher percentage will assume the higher range. So for account 1, you will have range from 0 to 4, and then for the second account, you have the range between 5 and 99. That's how we did it. So multiple advantages of this is, first of all, you can do a hybrid storage solution. You could do migration from, say, one account to another, or migration from one region to another. You could also do, with this solution in place, you could you could deprecate the traffic going to one account or one storage to another, because all you need to do is just set the percentage to be 0 for one of the account or one of the type of the storage. That's how we migrated initially from Object Store to Azure. And with the account distribution in place, now we need to have a good strategy for the failover. Our initial strategy for the failover was designated group of accounts. It was a primary group of accounts and the secondary. The idea was that if you do number of retries on the primary account and it fails, then the secondary account will kick in and take the slack and does the upload. The strategy overall works fine until we run into a few situations when the primary accounts were not performing for a long period of time. With this strategy in place, it introduced inefficiency, because every time you try to upload into a non-performing account, you wasted time on the retries, up to 10 seconds, and then you failed over to the secondary account. We immediately saw performance degradation when this happens. So our next evolution for this was to introduce the circuit breaker. So we got away from the secondary accounts, and every account became a primary account coupled with a circuit breaker. So if this primary account was not performing, its circuit breaker was open. So when dispatcher made select this primary account, it first looked at the circuit breaker and saw that it's open. In this case, it will just pick the random primary account from the list of the primary accounts with the circuit breaker closed and redirected upload there. So this strategy was instrumental in case when the data center failure. In this case, it was just all the accounts became non-performing for the data center, and then they moved to another data center in different regions. So what we learned in our endeavor to stand up this service to handle this huge load is that most of the time client libraries use blocking a HTTP request, and it's detrimental to performance under high load. We also learned that if you provision more accounts, it's not just for the size alone, but in general, if you have many accounts, it gives you smoother performance with less spikiness. Traffic shaping was also useful in having the resiliency and having the hybrid deployments. And the circuit breaker failover was the best strategy that we could come up with for handling like massive or catastrophic failure of one of the data centers, if that's ever occurred. So with this solution in place, what we were able to achieve, we upload about 1 billion segments a day. That translates into 11,000 requests per second. We extract 32 million events per day, and our total aggregate storage is 2.5 petabytes. Thank you. Appreciate it.
Thank you, Arkady. And sorry for running over a little bit. We will wrap up soon. So I want to touch a couple of things on this open interoperable layer. We're going to cover this in a lot more detail later in the big data talk this afternoon. So just a few things. We have a Go client library that we're adding to our large stable of different open source libraries. We have support for both Windows, Mac, and Linux with a lot of our .NET Core work, as well as the command line interface, which is Python-based and runs really well on all platforms. We are also launching, we have a preview in place, it has been for a couple months now. AZ-copy, for those of you who are familiar with it, now works well with Linux. So that's something you can go use. It's our robo-copy for Azure Storage, basically. Used to work on Windows, worked really well, now works on Linux. We're also building a blob fuse adapter for Linux. So if you're familiar with the fuse adapters, you can now mount your blob storage account as a file system, as a device under Linux, and do a lot of POSIX file system-like operations without needing to go upload and download data. So that's going into preview by second week of October. And I think that will really end up helping HPC and big data workloads that run on Linux VMs. We also launched Azure Storage Events, which are now in preview, and they allow you to do a pub/sub mechanism for data write. So rather than going and polling at a blob storage container looking what's changed, you can now sign up with the new Azure Event Grid service and get a notification every time a new blob is put into an account. So this allows you to build those serverless workflows with Azure Functions. So you can have a data write land on blob storage, kick off a function, kick off a container instance, do a little bit of work, and wrap up without having to run a bunch of VMs. This is in preview now. It'll GA first half of next year. The last piece that I want to cover is support for the S3 API. This is an interesting thing because many people, even who are not using AWS, end up using the S3 API for on-prem object storage systems. You may want to use those side by side without really needing to change your code. So the way we've been approaching this is with a partner-based approach. So you have this variety of data deployment and cost models. And the key tenet for us working with these partners has been that you can upload data in through the S3 API, but then you can access that data with the Blob API. So you don't break all of that integration with all of those Azure services that I talked about. So the way this has been implemented by our partners is usually by having some form of a proxy or a gateway, either a virtual machine or a container that can sit in front of Azure Blob Storage. They take in the object over the S3 API, they translate it to the Blob object, they keep some metadata that is incompatible, but then the object inside Blob Storage is accessible via the Blob API. So very pleased to announce the S3 support from a number of partners today. They're all either there now or coming in the next month. So for Caringo, Cloudian, Minio, Nuba, and Scality, all 5 partners have S3 support on top of Azure Blob Storage. So please check these out. A number of them are at the expo, or if not, we have data sheets at our booth so you can pick up and look at them and see what they do. So that's about all I had. I know this is a little bit longer than I was expecting, so apologies. But hopefully in this talk, you've looked at all of these different pillars and the new features that we're building here, and particularly archive storage blob level tiering, the scale and performance increases, the network access and encryption enhancements, and Azure Storage Events for serverless workflows. If you're interested in learning a little bit more about blob storage, I'll leave this slide up here. If you want to chat with us, we'll of course be here till 10:45. But also, if you want to meet with us, that's the link, aka.ms, meet Azure Storage. Drop by the booth anytime, of course. If you want a little bit longer time, feel free to talk to us there. Thank you so much, and have a good rest of your Ignite. Thank you.